All right, welcome everybody. Thank you so much for joining today. My name is Bo. I'm with Acelab. We're helping out with hosting today's event. It's presented by Kevin Cox with ATAS International. I'm going to go over a few quick housekeeping things, show you how to get in touch with ATAS on Acelab so that you can follow up with any questions really easily after today's event. My colleague Arman is joining today as well, and he's going to give a quick little intro about Acelab and how Acelab works with architects. That should be about 5 minutes or less, and then we'll get started with the CEU portion of today's event. Today's event is AIA approved and IDCEC approved. So we did ask for AIA numbers upon registration. I'm also going to send over a quick form in the chat in a moment or so where you'll be able to include your AIA number if you didn't add it yet, as well as your IDCEC number if that's something that you're looking for. So those credits will get reported directly. And if you have any issues, you can follow up directly on Acelab, or Kevin will be sharing his information at the end of today's webinar as well. All right, so just real quick, I'm going to take you over to Acelab, show you how to get in touch with the TAS, and then my colleague's going to give you a little bit more information about Acelab. So anytime you log in, you've got this handy dashboard where you can see all the work you're doing. And if you know exactly the manufacturer you're looking for, just type in their name at the search bar at the top. You can head over to their page on Acelab, and you can get in touch directly with them here. So you can just click this contact button. You'll be able to include project details if it's a project-specific request. You can select a product if it's a product-specific request, and you can explore more about their products right from this page. So this is a great place to come after today's webinar if you want to get some more information about the products or get in touch with today's course presenters. All right. Some other housekeeping items is I just want to mention that we will be doing Q&A today. So if you have any questions, please feel free to submit them in the Q&A box throughout today's event. We will have some time at the end to answer them, and we'll have a record of everyone's questions if we don't get to your question today. All right, looks like Arman is here. So Arman is going to give just a quick few minutes about Acelab and how we work with architects, and then we'll go ahead and get started with today's CEU portion. Hey, Arman.
Great. Hey, Bo. Hey, Kevin. Thanks for letting me join. For those of you who don't know me, I'm Acelab's Director of Architectural Partnerships, and I work very directly with architects to help them on a day-to-day basis with material specification and building out their firm library, which I know a lot of you start and definitely need some help to continue building. In fact, this morning I spoke with an architect that Kevin in the ATAS territory is looking for some nice shingled metal products, and so I pointed them to your catalog, which is extensive. And so just to give you a quick overview, and then we can chat about this at a different time, so please feel free to respond to the survey that Bo will send out in just a bit. The way I work with architects on a day-to-day basis is really helping architects build out their material libraries and then providing expertise on their project through those material libraries. You'll get access to not only myself, I'll be your main touch point, but our entire architect and design and also specifier team in our Acelab group that can help you with any questions that you have. So just to show you quickly what a question can look like through this process, architects ask us for all types of different things, but the primary things we're able to help with are material research and recommendations for products, similar to the ATAS recommendation I gave this morning, or also comparison or substitution reports for products that you already have as part of your basis of design. We're able to provide alternatives that are either performing better than the ones you already have, might come at a better cost, perform better in terms of sustainability, or the manufacturer is just more responsive as a whole. And that's really important to a lot of architects. As part of that, we also will connect you with the manufacturers that we suggest in order to make that process a little bit smoother. One example of a question I got from one of the architects I work with on a regular basis just in the past month was about looking for a low-cost prefab panel system for a small ADU that they're building out. They wanted something that didn't have them latched onto a specific cladding system. And after some research, while I know that the market is saturated with a lot of ADU products, we were able to find a product called Preflex that is an out-of-the-package SIP prefab wall system out of which they could build a small product and then clad it based on their own selections. And so that's a really quick question that an architect has given us that we were able to respond and connect them with the manufacturer through. If you'd like to get started with this process, please reach out. We'll drop a link in the chat and also send out a survey, and we can discuss this in a 30-minute chat in the next week or so. And now back to you, Kevin and Bo. Thanks so much.
Awesome. Thanks, Armand. All right.
Thanks, Armand.
So that poll, Armand will send his meeting link in the chat as well, so you can go ahead and book a call directly. And now, without further ado, I'd love to hand it over to you, Kevin, to get started with today's CEU portion.
All right. Thank you so much, Bo. Let me get our screen up here, and we'll get started on today's architectural metals for the interior world. I want to thank everybody for showing up today and spending a little time. We'll get right into the meat of the program. So today's presentation is worth 1 CEU in health, safety, and welfare, as well as IDCEC. Please send us your numbers in the chat, so we'll make sure that we get you those certificates out. The material you're going to see today is copyrighted. No reuse or rebroadcast without the express written consent. Now, that all being said, the very last slide is my information. So have those screen captures or cameras ready. There's anything that you see that you need in the presentation or would like to have for your own use, your own marketing ideas, or just to take a look at or to delve in deeper, please reach out. We're happy to share. Always like to get involved with projects and get into the design community. And generally, I've written a couple of these presentations. One was very technical. It was reverb calculations, and it was a little bit dry. And this is kind of the answers to that. What we're going to see today is really lots of ideas, jumping off places, and points that we can use a very, very sustainable, earth-friendly product in our interior applications. Our learning objectives for today is we're going to examine how cost-effective aluminum is, as well as sustainable, its green nature, its attributes, the places we can get lead points out of it. We're going to look at a wide variety of colors, textures, processes, all different things we can do to really expand that palette as we move these architectural metals inside. We're going to create and show intuitive ways to use metals in walls, ceilings, artistic pieces, focal points. And we're going to take a look at kind of conventional methods and see how we can replace those methods with, once again, a more sustainable, planet-friendly aluminum product. And last but not least, we're going to look at how metal can enhance interior environments with beauty, strength, durability, and resilience. So first, a couple of statistics, and these are a little alarming, but the annual construction waste is expected to reach 2.2 billion, that's with a B, billion tons globally by 2025. Construction and demolition waste generation in the U.S. increased by 342% from 1990 to 2018. Now, we know the population didn't increase that much, but the construction waste did, and it's started to clog up landfills, started to increase awareness. And more than 75% of all construction waste is going to come from wood, drywall, asphalts, shingles, brick, and clay tiles. Now, 75% is really an estimate. This figure could be higher. But if you notice, there's one material that's missing from that list, and that's metal. So what can we do? Well, we reduce, reuse, reduce, and recycle. We take the related stress of using recycled materials out of them, and we can put them back into service. Efforts can reduce expansion of landfills by 1,000 acres for every 135 million tons of construction waste. Obviously, the less waste, the less refuge, less in landfills means less greenhouse gases, means a healthier planet. And most everybody knows what the solutions are, but are we putting them into practice? When we look at aluminum, not only is aluminum an economical material, but it's one of the most energy efficient, sustainable construction materials. Third most abundant element on the planet, very, very versatile. It's lightweight, durable, corrosion resistant, and best of all, it's 100% recyclable with no loss of its natural properties. So what that means is that aluminum products can be dismantled and reassembled, reused infinitely without that loss or the molecular concept. So it holds its allies, it holds its molecular structure, and it doesn't lose anything as we recycle it time and time again. Another piece that really, really makes this come into focus is that it only requires 5% of the energy needed to recycle aluminum than it does to produce a virgin material, to actually mine it. So if it was $100 per 10 ounces, it would be $5 per 10 ounces. So it's much more cost effective to recycle this material. So that high scrap value, it's easily separated from other materials. It's often used to offset demolition costs by reclaiming and recycling. And one of the most really standout statistics, and there was a range from 75 to 82, but the low end, 75% of all aluminum ever mined is still in use today. So before Greenpeace demonstrations, before LEEDs, before the current push to recycle more materials, aluminum inherently lends itself to be repurposed indefinitely. And that's why we use it in so many places. I'm not going to go through all the list, but when we look at window frames, curtains, walls, solar panels, bike racks, just about everywhere you can think of on the exterior places, we use aluminum for all the reasons: for strength, for durability, and for corrosion resistance. So migrating metals to the interior design, it brings all those advantages. It really makes sense. And that added sustainability and continued reusage, we can bring that into our interior environments and relieve some of the stress that's going into those landfills. On the right is the bay opening. It's Ontario, Hilton Garden Inn, large columns, very neo-industrial type look. And on the left, those are aluminum panels there up on the top, those triangular panels. And that is out in Mesa, Arizona. They were actually trying to catch a desert Southwest motif. So they have the natural sandstone laying in, the grays and the blocks in both the wall cladding, as well as that soffit coming in the vestibule. And then the focal point being that diamond back sort of rattlesnake looking backdrop that's behind the reception office. I think they've done a really nice job kind of catching that motif up. So the versatility of aluminum and other metals really creates limitless applications. We have longevity. We can blend form and function and beauty and style. When we're taking a look at this one, this is the Meow restaurant in New Orleans, just outside of the French Quarter. It is a cat-themed restaurant, multi-level. Cats normally don't like water, but the design intent here was to create an area that was above and below water, and cats underwater, kind of a misnomer, if you will. And you can see that top is a peened, highly polished, brushed and mirror finished aluminum that kind of gives you that feel like you're in water looking up. So let's look at all the different attributes metal can bring into your interior spaces. We're going to start with textures and finishes. So there's a wide variety of colors, finishes, textures. We can do spray type paints, powder coats, several continuous coil coating processes with polyvinyl iodine fluoride, or PVDF, or siliconized modified polyester, SMP, as well as other high performance systems. Above and beyond that, there's anodizing, wood grains. We can simulate weather materials. We can actually weather materials either naturally or accelerated with chemicals. We can utilize natural metals. We can also do embossing and textures. This job above was designed with a very specific wood grain. It was an oak wood grain, and they tied everything to it. The wainscots, the desks. It's Moser School out in Rocky Hill, Connecticut. So everything in this learning center for this magnet school was all this wood grain. And when you look at this picture, that ceiling panel is actually metal with a PVDF wood grain on it. And that wall panel on the side is a true veneer, a wood veneer that's finished and then laminated, probably to an MDF, I believe is what the board is. But you can see between the true wood and the simulated wood, both really look like a natural wood grain. They give you that nice, warm, organic feel into that space, but without the upkeep or the delamination or the things that you have to do with an actual wood. Wide array of colors, glosses. We can work with mattes, metallics. This is actually color shifting paint. So the color changing paint is visually different depending on the light and the angle of the viewer. This is an exterior wall, but we've done some interior products too. This is the Pine Grove Middle School in East Syracuse, New York. So spray and powder coats. Spray is generally a wet process that uses air as a propellant and a drying agent to create a finish that's adhered to the product. Generally, these are things that are already pre-assembled. The same is true for powder coating. It's also a dry process, where we create an electrical charge to the metal itself. And that electrical charge almost creates a magnetic draw, and it brings the powder that fuses to the metal surface. Both of these processes can use a post oven or baked to cure and harden the finish. And we can use a number of types of paints with the processes: acrylic, polyester, PVDF, polyurethane, and epoxies. But generally, it's going to be, when we're looking at sprayed and powder coats, we have something that is already assembled that we want to coat. Now, coil coating offers the highest quality and premium finish. It's going to give you the most consistent thickness, the longest lasting performance, but generally we're doing this in a prefabricated site. These are all pictures of coils and coil coaters. I'd like you to pay attention to the picture on the left there. That is actually looking down at an accumulator. And when we're looking at the coil coating process, that's a pretty integral part. Reason being is that this line has to continue to move. Now, this line works from right to left, the opposite of reading, but that's kind of how our line runs, and that's why this diagram goes that way. When you look at the far right side, that payoff side, well, that's what we're switching. We're switching different materials, different gauges, whether it's an aluminum, an 032, an 040, or we're moving to a copper or to a galvalume or some other product. Well, that line has to continue to move, otherwise things get kind of overdone or overcooked. That zigzag that you see, that accumulator, that entry accumulator, literally accumulates material. And then as we can stop the front payoff side by taking that material that's accumulated and running it through the line. That way we can change gauges, we can change metals. It's going to run through that accumulator. We're going to stitch one coil to the next and continue the line. Those accumulators come back up, so we have that time built into it, but the line continues to move. Starts with a cleaning and pre-treatment section. This is an etching, kind of prepares the metal to receive either a primer or pigments or whatever the next coat is. In a coil coating line for PVDF, the next coat would be a prime coat. Then that's going to go into a curing oven that hardens it, a rinse to remove any impurities or anything that's left over. It winds back around. Now this line currently is about the length of a football field. It does go up and down, otherwise it'd have to be the length of almost 2 football fields. So we wind back around and come down, and that's where the finish coat happens, another curing oven, and then there is a section that we can do laminating, embossing, post processes on the coil to where it goes back up and around. Then you have that exit accumulator. And it's the same thing as the entry, but on the opposite side. So when we rewind, finish, and inspect that last coil, we're going to put a new core on there. That has to stop. So the material actually goes up into that accumulator. Those rollers separate. The upper ones move up toward the ceiling, and that's where the material is being accumulated, so we can change, put on a new core, and start rolling a new coil. The end product is basically this. You see the aluminum, that's that base metal. The complex oxide treatments are the etchings or the prep. These are usually gone. They're taken off by the final rinse. The next layer is a compatible primer. And then you see on the bottom is a backer coat. Generally with metals, one side's going to be visible, one side's not going to be visible. So we want to put our best foot forward or on the visible side. So that top coat's going to be the PVDF. That backer coat or the wash coat is going to probably be a lesser paint because it's not going to see the light of day. Unless we have a perforated two-sided type application, some screen walls, some parking garages where you're going to see both, then we'd be putting a top coat on both sides. So it would be a two-coated product. This looks exactly the same if we're using steel, but generally steel is going to have a zinc coating or an aluminum zinc coating as an additional layer to prevent corrosion from weathering. Wood grains and wood grain technologies have really come a long, long way. We can get some great facsimiles and bring the warmth of wood in, and once again, without any of the drawbacks that a natural wood can bring. There's 3 processes generally when we're looking at wood grains. There's a laminate. That's basically a pressure and heated roll or film that's placed over the face of the metal, heated up so it adheres. There's a powder coat. Powder coat, generally they're going to put the first coat on, which will be the lightest, and then either an applique or a sublimation process to create the wood grain. And last but not least is a PVDF. Once again, we start with that lightest coat, but instead of a sublimation process or some type of print over it, we're going to have a roller, a species roller that will lay the wood grain on with a PVDF ink. And then we're going to put a coating on that process, and that locks in that paint and stabilizes it for UVs. Usually most manufacturers are going to have a 30 to 35-year warranty, probably a 50-year expectancy. That cherry and medium teak that are in the center, those are both laminates. The powder coats are off to the right, and the PVDFs are there at the bottom. Couple examples. The job you're looking at on the left is actually Tanger Outlets. If you guys have ever been at a Tanger or Tanger Outlet, it is kind of an outdoor with canopies. That installation is about 18 years old. I was there last summer. It looks just the way it does. Some really nice detail and mitering on the corners. A job on the right is the Quadrant. That is also in Florida, but up in Jacksonville. Once again, both these jobs are within a mile of the coast. They're PVDF wood grains. The one that's 18 years old looks brand new, and so does the one that's only 4 or 5. Distress finishes in Core 10 is the kind of design to show a weathered or a distressed type look. This can be achieved through natural aging. We can do chemically accelerated aging, or we can do a simulated process. That one on the right there is, you can see the rust in the corrugated checkerboard or moved panels into a grid. Kind of gives a very rustic sort of Old West feel. On the other side, that's actually a dentist office, and that is an oxide series, very similar to the wood grains. We're starting that. It's a PVDF. We're starting out with a base color, and then there's a roller that puts those distressed imprints on top of it in a darker color. You can see the tarnished red or the copper browns, and gives it a very kind of old, weathered, used look. Now, the issues that we have with Core 10 when we get to places that have any type of humidity is that it doesn't play nice with adjacent materials. So it will bleed onto materials, it'll literally rust onto them. When we do this in a PVDF, we can get a very similar aesthetic, but we don't have, it plays very nicely with all of its adjacent materials. Nothing runs, creeps, or moves from one space to another. Now, anodizing uses the natural oxidation process to create a hard abrasion resistant finish called an anodic layer. On the left there, that is a private residence. Those panels are actually the same type of triangular panels you saw in the Mesa picture, except for these are anodized, so they're all that similar color to give it a nice, shiny, bright metallic finish on a very light radius that kind of runs with that staircase. On the right, that is a dark anodized. That is a Shake Shack in Chicago, Illinois. Process also lends itself to unlimited numbers of colors and finishes. That's the Hawthorne Showroom, 125 Park Avenue, New York, New York. It is open if you're ever up in the city to see it. And the other one is the Qingzhou Provincial Radio, Film, and Television Group Theater in Qingzhou, China. A very vivid, bright red color. And the process is also a 3-step process. There's a pre-treatment, very much like the etching, where the material is cleaned and treated to make sure that all of the contaminants are removed from it. Then we put it and submerge it into, instead of a coating, but electrolytic bath. So a fluid that we pass an electric current through, and that starts to grow an oxide or anodic layer. It's integral to the metal. It's not really like a coating, but it grows. And the longer it's in that electrolytic bath, the thicker that anodic layer will grow. When that's finished, it moves on to a rinse and a post-treatment where they can add dyes, salts. They can put deposits in it. They can actually create a large spectrum of colors, like you saw at the Provincial Theater, brightnesses, reflectivities. They also put additives that will enhance RV resistance or UV resistance, so we're not having fading if we have direct sunlight. And they can also do some sealing processes in the post-treatment because the cells are very, very organized. So the oxide layer is a natural process. Once again, it's accelerated and controlled to achieve a desired thickness and finish. You can see both in the high-powered microscope and in the drawing that the cells are very well organized, and the pores are long, so it's very easy to fill those with pigments, salts, sealants, and so forth. And once again, we wind up with a wide array, a very big and broad palette that you can use to meet just about any design intent. So that's the basic process, but there's two ways of getting there too. There's batch anodizing, and then there's continuous coil operation. Batch anodizing is basically a dipping process into the electrolytic fluid. The issue or the end result is that that first piece in will obviously be the last piece out because you're dipping it. The result is that that last piece out is going to be slightly thicker than the one that was first in, first out. So when you look at that top drawing there, that top photo, that's actually a Hyundai in China, and it's kind of varied. It's almost like a zinc would have a varied finish. So you get more of a leather type appearance that's not very consistent. They decided they wanted a consistent finish. And if you look at the bottom picture, that is a continuous coil operation. The coil operation for anodizing is very similar to coil coating. It's almost that exact process of going into a pre-treatment, but instead of going into a no oven, and instead of going into an actual paint, it's going into an electrolytic bath, and we're passing current through it to grow that anodic layer. Work with natural metals, zincs, very, very popular, especially in Europe. Gray in color, but we can do pigments to create different colors and finishes. The pigments aren't always very UV stable, so eventually zincs will usually patina back to gray. We can't really tell how quickly that's going to happen, just that it will happen. So it's just something that if you're working in zinc, you want to set the table. This process of patinaing or going back to gray with pigmented zincs is greatly elongated when we move them inside, when they don't have direct sunlight or direct UV. There's kind of some examples of the pigmentations that we can do. That left side is a private residence in Los Angeles. This may not come as a shock to anybody, but most of the private residents you're going to see in the slides today are generally designers' homes, just kind of adding a real nice flair or spark with them. And on the right, that's actually it's a mock-up, sample mock-up that I saw in British Columbia. I just thought was kind of cool, so we added it here today. More natural metals, copper, stainless steel, brass. We were asked if we could roll form brass, and at first I think the answer was I don't know. It turns out it's very, very similar to copper, and the answer is yes, we can roll form brass, and it's you can see the row in Palm Springs, California there on the right. We can also coat coppers and natural metals to lock in their current finish. So with either a polyurethane or a top coat, we're removing the elements from it. We can literally age it. If you look on that left, that's the Onslow House lobby in the United Kingdom. And those are patinaed or accelerated and then coated. So they will continue to hold those colors for the life of their existence. And then we have a corporate office, nondescript corporate office, a large format, heavy gauge panel there with a natural finish in the center. And with those natural finishes, we can take them from mirrored, highly polished chromes to mills, brushed, and then all of the phases that are in between those. The results can be pretty astonishing. We have on the left there, that is the Sky Harbor Airport in Phoenix. The photographer is yours truly. So if anyone wants to use that, please let me know. The other one's a really nice one too. It's a very, very heavy gauge. They want to get almost like a Swiss cheese effect. That is the coffee shop at the Lone Star College in Houston, Texas. And it's a crisscross brushing, and then it's not even a perforation. It's really more holes at different sizes and different levels to create that Swiss cheese sort of motif. Finish can take shape in multiple directions. That's the life insurance, Texas Life Insurance there on the left in Waco, Texas. The middle is the Ohio Food Bank in Grove City, Ohio, and the MBTA Courthouse Transit Station there in Boston, Massachusetts. And that is a freeform multi-directional brushing. That center picture with the food bank, that's done with pyramid rollers. You can always radius a corrugated panel along its corrugations. We kind of call it curving it the easy way, as long as we're putting it to a substrate. With the pyramid rollers, we can actually curve it the long way and get that long, nice arc out of it, and putting it under a desk and kind of creating a focal point. Commercial applications can range from manicured, that checkerboard that we see on the left, or to a more rustic, that through fasten panel that we have on the right. A lot of times they're mixing sort of this industrial or older look with natural organic finishes like wood. And it's not just commercial applications. We can add resilience and beauty to residential installations too, as in both of these examples. And once again, a more manicured pinstripe look there on the left, and then that sort of rustic mix of natural woods and that alumazinc or mill type finish in a corrugated panel. More options, more ways we can utilize metals is through embossing. We started using embossing to kind of hide imperfections, especially exterior. When you have a lot of expansion and contraction, sometimes metals will tend to oil can, especially when the installation is really tight or new. So they started using embossing to help mask some of that. As we move these metals inside, some of those embossings became an aesthetic. And although we don't have thermal expansion and contraction, they're still kind of adding a new dimension and some more pieces or directions that you can go with your design intent. The top one, that's a stucco embossed panel. We have a light diamond plate texture there on the left. And on the right, that is a wood grain, simulated wood grain panel in a PVDF, but then with a rough cut cedar embossing. So it looks like it's a rough cut type board, and yet once again, it's metal with virtually no upkeep. Beyond embossing is perforations. Perforations can take all shapes and sizes. They can be aesthetic, functional, acoustic, or really any combination of all the above. There's a freedom to design with size, shape, orientation. We can make wall panels, acoustic panels, whether they're functional, acoustical, or just aesthetic. Their impact resistance makes them ideal for high traffic areas, especially areas where we have a lot of flow or egress, which all of these are examples of. Not only do perforations come in all these shapes and sizes, but although traditionally they're uniform, they don't have to be uniform across a panel or a ceiling or a wall or any visual plane. So a non-symmetrical layout can create a visual impact that almost draws the eye to it, as you see in both of these examples here. So it seems counterintuitive, but metal can also provide a very, very proficient acoustical benefit. Perforation is going to allow sound energy to pass through the panel and be captured in the cavity by some type of absorptive material. So from the visual side to the wall cavity side, that perforation allows that sound energy to travel through it. Once it's trapped inside that cavity, we can catch it in several different ways. The first, in a very common way, is an acoustical fleece or backing. This is a very thin film. It doesn't particulate. It doesn't take up any of your interstitial space. It's acoustically transparent mastic that's heat activated, whether it's through hot air or an iron. That mastic will adhere the acoustical fleece to the panel. So whether we're going horizontal or vertical application, it's adhered and kind of married to it once it's factory applied. And we're going to get an NRC of about 0.70, 0.75 across the relevant frequencies from 250 to 2000 hertz. And that's exactly what NRC measures, is the amount of sound energy absorbed, average across those hertz, and rounded to the nearest 0.05. So we're getting 0.75 NRC. That means that roughly 75% of the sound energy that hits that panel is going to be absorbed. CFAB, or cellulose fiber acoustical bat, is a synthetic fiber made out of denim and polyester. It's treated to pass NFPA 285. The nice thing about this is, one, it's highly recycled and highly recyclable. When we're looking at a 2-inch bat and something between 18 to 22% open, we're going to get perfect absorption, or an NRC of about 1.0. So we can maximize our acoustical benefit and be kind to our planet by using CFAB. Being that it is a natural synthetic fiber, it's a little bit more expensive than fiberglass. Thus, the most common type of acoustical absorber will be a standard fiberglass, usually about 1.5 density, 2 inches, and you're going to get about the same acoustical effect as you will with the CFAB. So we'll get a 1 NRC, or perfect absorption, with a perforation about 18 to 23% open. Generally, we need to put some type of black facing or scrum on standard fiberglass. It's just made from spun glass fibers matted together. But depending on the manufacturer, it's bright yellow, it's bright pink, it's bright green. And if we have a perforation, sometimes we can see those colors telescoping through. If you don't want to see that, we're generally going to put a scrum or facing on it to shroud those. So even less money if we use HVAC duct liner, because the product is more commodity. It's used to isolate or reduce velocity, wind velocity sounds in ducts, but it does have an acoustical rating. So if you have somebody, I know this never happens in the world out there in the design community, but they have a champagne taste, but more of a beer budget, this is another way to save, especially over large square footage, some dollars and cents. This is the job that's near and dear to my heart. This is the Reynolds Coliseum Hall of Champions. And it was designed as a retrofit. This was where Jimmy Valvano played in the 50s. They did a mezzanine, complete HVAC mezzanine, because it only had steam boilers at the time. There was no air conditioning. And they put in this large Hall of Champions. And it was designed to do fundraising, to have events, and to induct Hall of Fame athletes. Well, no one really thought about the acoustics, so when they went to use it, it was so echoic. They had an RT60, or a reverb time of about 5 or 6 seconds, that they couldn't understand what was being said. The solution was those tricolored, micro-perforated, factory-folded edges. Sound panels on the side with a 2-inch sound bat on a girt. Generally, for an auditorium area, you want to get the reverb time down under 2 seconds or so. They got it to about 2.3, but at least to a place where they could use that space for its designed intent. So not only can we absorb sound through perforations, but we can also use it as a parabolic reflector, or reflect sound back into a space. Usually the deeper the profile, the more it's going to grab and focus the sound. Both of these are in malls. It's a Shake Shack on the left and a Blaze Pizza on the right. Nothing attracts a crowd like a crowd. So we can use it as a reflector. Some of these spaces, you'll notice neither of those have acoustical ceilings, are designed to be a little louder so that we can bring some attention to the space. And during lunchtime, hey, maybe it's time to get a burger or get a slice of pie. So let's look at the traditional ways that things are normally done and how we can do them better and more sustainably with aluminum. So these are all fabric wrapped sound panels. You do have a pretty wide palette as far as shape and color go. They can be a dot matrix, or something that's a visual impact or a focal point. We can do branding or school colors. Or they can be muted colors like you see on the left, that sort of fall back into the design there, and are really just there for the more utilitarian purpose of reducing reverberation and controlling sound. When we move into metal, wall panels can still be separate modular units mounted to the wall via Z-clip or some other mechanical attachment. These panels will provide all the same attributes as their fabric wrap counterparts, but at the end of the day, when they're done, that aluminum is going to be recycled. It's not going to wind up in a landfill. And all the things that you can do with the fabric wrap panel, you can do with aluminum panel and more. We can separate units and combine them, hung them side by side to create large planes of either visually ondulated panels like you see there on the left, or flat monolithic panels, both of which are acoustically proficient. We can take a girt and actually clad entire walls to create hallways or complete surroundings or envelopes. that are acoustically absorptive. Entire wall surfaces can become sound absorbers. So whether it's educational, industrial, office space, they can all be enhanced acoustically with microperforated metal with sound absorbing materials behind them. The one on that lower there, that's more of an industrial area that we did. And if you notice, you can see the white lines behind that, and that's for impact resistance. When we do perforate metal, it does lose some of its structural integrity. So when we're looking at an industrial area or a high impact area or an egress area, we either want to greatly increase the gauge or frame it out and not perforate the exterior of the panel, thus giving it more impact resistance. Another job that I had the pleasure and the benefit to work on here is the Carrie Gabby Rec Center in Brooklyn, New York. This center serves the Brooklyn community to come together in a bright, open, multi-purpose recreational space. It's designed for soccer. There's an aquatic center, baseball, yoga, dance, fitness, and it's an acoustically backed micro-perforated aluminum walls, create a sustainable, impact-resistant, and acoustically proficient partition that allows for very, very high decibel recreation to take place, rain or shine. So just using metal as cladding as opposed to our good old friend gypsum drywall, it really can give your interior some punch and some pizzazz. Metal can provide corrugated, undulated surfaces. That's another Shake Shack there on the left. That one's in Tokyo, Japan. Or we can get these flat, monolithic, almost ACM, MCM type panels that you see in the Austin Bergstrom Airport there on the right. Perforations don't have to be acoustic. They can be backlit. They can be graphic, used as shading devices, or just purely decorative. In that modern conference mall, we have a graphic lobby in the center. And then once again, a designer's kind of breezeway home there on the right. Anything you can do with a micro or a standard ceiling tile, we can do with metals. So any of the configurations, any of the grids, whether it's revealed, we can actually do a reverse reveal. So the panel goes up into the ceiling, but these can all be done. So that mineral fiber, they don't really have a good way to recycle that. It's made from slag, which is a byproduct of steel production. But with aluminum, we know that this panel, when it's done with its life, is not going to wind up in the landfill. It's going to come back as something else again and again and again. Flat, solid, perforated for beauty or for acoustical absorption. Metal is going to provide a wide variety of options. And like metal wall panels, they're really limited only by the imagination. Grid has become so abundant in building that we've worked now to conceal grids. And this is another thing that's very, very easily achieved by the use of aluminum or metal panels. This is a torsion spring system. Basically, they slot the face of the grid and the torsion springs will fit up into them. You can push that panel up, the spring expands, blocking the panel and concealing the grid. You do the opposite to achieve egress or access into the ceiling. The nice part about that is you pull that panel down, you can squeeze the two clips that are closest to you, let that panel down, get egress into the ceiling, and the panel will hang there undisturbed, can't get run over, can't get kicked. And when you're done, you can put it all back together. Also, these are beneficial in any areas where we're going to have uplift. So we can move from a vestibule to a soffit and not have to worry about these panels blowing out in a high wind event. Here's some examples, a curved HVAC coming through it, but these are rectangular panels there at SAS Institute on the left, or the Newark Airport on the right. Lift and shift. This is another way of concealing grid. There's kind of two sort of ways that we go at this. One is a panel that shifts in between. So it's a deep curve in the panel. You push it up into the face of the grid on one side, all the way in, push the panel in, and then center it to engage it. The other way is kind of a cantilevering. That back piece of the panel actually has a curve cut into it and it rolls under the face of the grid. The opposing end has a lip that lays on the top, and they're still point accessible. But one is downwardly accessible and the other one is upwardly accessible. So the same aesthetic is achieved, but these are strictly interior type applications. If you have inadvertent lift or wind, it can dislodge the panels. So we keep these in for inside applications only. They are a little bit more cost effective. Another way of concealing grids is hook-on panels. The suspension can be the traditional 15/16 grid and use a standard one-directional hook-on system, or there are proprietary systems that have latches and other pieces that keep the panels from disengaging. So here we have a large format hook-on system. On the left, that's the Allure Bank in Warsaw, Poland. The right is a mesh system that's hooked and clipped to avoid disengagement under those high wind areas. Geometrical ceilings. When we look at metals, we can take things that used to have to be square and rectangular and really push the bounds. Like the triangles you see above on the left there, trapezoids, hexagons, even parallelograms like you see on the right there. That's the terrace building in Southern California. They needed egress into some of those areas, but all the ceilings were angled. So they created parallelograms into a torsion spring system. But they don't have to be just two-dimensional geographic systems. Geographical shapes can go as wedges. They can extend, they can invert, angled panels, all make it possible to move ceilings and walls from two-dimensional applications to three-dimensional applications. Clouds and floating ceilings. Ceilings don't have to be wall-to-wall anymore. They can float, they can sit, they can be design elements as well as acoustic elements, and even further extend design possibilities for the design professional. So traditionally, acoustical clouds or acoustical absorptive clouds use a fabric wrap panel very similar to the ones that we'd put onto the wall with a chemically hardened edge, usually a matte fiberglass or semi-rigid fiberglass. A nice thing about these panels is that you get a two-pass benefit, so you can use less square footage. You can work with shapes and geometry a little more. So that first pass that would hit a face would be absorbed on that first pass, but anything that goes above that, that would hit structure, the back sides of these are also absorptive. So once again, you get that two-pass benefit, and you need a little bit less square footage to treat a space. Aluminum can enhance the sharpness and visual impact of these floating elements with all the advantages that come with the standard panels, like the two-pass benefit. And then we can make trim edges either by turning the panels up on their ends or by creating another element. Edge trims can be extruded, break formed, roll formed, straight, radiused, vertical, horizontal. Anywhere where we want an edge, it's not going to go wall to wall, whether it's going to be a light pocket or a roll up shade or just a floating element. This is how we can trim them out with yet another element and even further expanding design potentials. Different styles for every intent and application. Open office non-symmetrical concept on the left, a metered and organized sort of layout on the right, and then the mixing of woods and then a white aluminum banding there in the center. Linear ceilings, these were popular in the 80s and 90s. And I think it's really the wood technology that's brought them back. They've made a kind of a roaring comeback. So panels can be side by side, are spaced out with or without a physical reveal between them. That reveal can be recessed, flushed, integral, adjacent. Once again, the endless possibilities when we look at lineal ceilings. Wood advancements makes the warmth and beauty of wood available, once again, in a highly sustainable, recyclable, maintenance-free environment. So these are both PVDFs. That is the Muslim Institute on the right, Rocky Hill School on the left. And when you work with a PVDF, when you get a maintenance manual, it's literally, if it's an exterior application, it's 2 cold water washes. If it's an interior application, it's 2 dry cloth washes. Anything does happen to adhere to it, it's once again 1 molecule off of Teflon, so nothing really does. But if it does, it's a light soap and water. So it is virtually maintenance free. But we can utilize multiple widths in a single ceiling installation, multiple depths, pushing into 3 dimensions, or even mix wood grains and solid panels. All of these, once again, are expanding that design palette that's available with the use of metals on interiors. Moving deeper into 3D dimensions, installation of curved ceilings create additional visual impact that's really unmatched by its 2D counterparts. A couple ways we can radius lineal metal ceilings. We can do straight panels and radius the carrier, thus giving a sloping either convex or concave application. Or we can, once again, go back to our pyramid rollers. When we talked about doing it the easy way and the hard way would be doing it by the arc length. They're literally radiusing the panel. So on the left is a mall entrance. That is literally curving the panel up. There's an escalator that runs adjacent and under that. Or on the right, those are all straight panels, but on a curved radius carrier that are allowed that monitor and incorporate natural light into that space. Booth size panels can be also made to further widen that impact. On the left is over a conference room table, and on the right is over an entire car showroom. Beams and baffles even push the bounds of these linear assemblies, creating an illusion of a ceiling plane with space and accessibility to reach above that plane, like the Bronco restaurant there on the left in Rochester, New York, or the Sky Harbor Airport in Phoenix, Arizona on the right. We can make smaller celled units by crisscrossing these beams that still create that plane and a similar effect, but in multiple directions. The Millstone Hospital lobby in New York City on the left, or the Riddle Hospital connector in Media, PA on the right. Custom fabrications can lead us away from the constraints of square and perpendicular. That job on the left is the Rose Garden Tea Room. That's all, it's kind of outdoor. You can't see it, that was under construction, but above that is all glazing. So all of those units had to be removable so they could clean the glass above it. Each one of those nests in a structural assembly that goes down each side of those wagon wheels and creates that sort of spider web or wagon wheel effect. On the right, the terrace building, we saw the parallelogram torsion spring panels. Also with that were recessed 1-inch, 4-inch multi-length beams that went into these recessed areas, once again, creating a very, very unique aesthetic. Column wraps and covers, we can create impact resistance and hide unsightly structural members. Numerous options are available in reveals, collars, shapes, heights, attachments, single piece, stacked, or even lighted are all within reach. And it won't become a future landfill occupant when we use aluminum and we use natural metals. But all in all, when we're looking at metals, is you can't get over the wow factor or the punch or the visual impact that it provides. As a roof panel used as a wall cladding, they're in the Concourse Mall in New York City. And they wanted that to cover the entire walls, doors, anything that was on that wall, the in and out undulating on the wall. So we actually not only cladded the wall, but had to create a trim that was just slightly less than the door frame. So you close that walls and continue those lines, making it one continuous installation. On the right, those are actually metal strapping devices that a local artist put together with backlighting. I call it the eye in the sky, but it's over the front desk at a popular hotel up in Montreal, Canada. Here we have a recessed, maintenance-free, curved wood-look ceiling. You'll be seeing those at Fairfield Inns across the country on the left. On the right is actually a repurposed wall panel that they used as a ceiling between the glue lamp beams in a New York studio up in Brewster, New York. Eye-catching, multi-level, multi-directionals that are really made from one of the most planet-friendly materials available, aluminum. And it'll come back to deliver years and years of service, return to do it again and again, like above at the Vaughan Metropolitan Center in Ontario, Canada on the left, or at the BDC conference room in Montreal. It's hard to beat metal for resilience, impact resistance, sustainability, and beauty. Sure, there's a little more of an upfront cost, but can we afford to build with metal? Well, we really can't afford not to build with more metals. And we'd love to show you how. And with that, We have about 5 minutes left for questions. Guys, this is my information. Once again, we love to be a source, like to get involved in the design process. It's really kind of so much fun to get something that comes from, from an idea or from conception to completion. We have a lot of resources here, so please take down our information and reach out with anything we can possibly help out with. All right, Bo, do we have any questions?
We do have quite a few questions. There's 2 questions about like webinar certifications. I'm going to just get out of the way, and then we'll dig into some of the more product focused ones. So someone's wondering if this is US GBC approved. Do you know the answer to that?
It is not US GBC approved, not the Green Building Council.
And then what about GBCI?
No, it's AIA and then IDCIA.
Awesome. Thank you. All right. Let's see. What type of enamel used for powder coating is the most durable?
Depends on the processes. I am more, if you're looking for the most durable finish, it's not going to really be powder coating. It's probably going to be PVDF. I am more versed in polyesters and in the PVDF, the polyvinyls. So I would have to research that answer. If you can forward it to me, though, we have a sister company, Brightsmith Coil Coaters, that deals with nothing but coil coating, post painting, powder coating, and I can certainly get you that answer.
Awesome. All right. Next one, this is just more of a comment, but Michael says that they saw that color shifting installation in Syracuse on an architecture alumni trip, and their classmates and I were blown away by it. So
good. Glad to hear it.
All right. And then let's see, how are metal concealed ceiling tiles made for panels that are not the same size as standard panels?
Like that parallelogram job that we did, and we're working actually on a triangle job. You have to hit the grid modules that are usually laid out as 2x2 or 2x4, but where you put that torsion spring and where that slot is. So you have a triangle, but it's basically attaching points are going to be on a 2x2 module. So it's placement of the torsion spring itself and that punched hole slot that you push into. For those of you that aren't familiar, if you ever had the fan in your bathroom and you pull that fan down, it has little metal pieces, that's a torsion spring. And by the placement of those springs, even though we're putting it on, let's say, a grid, a 2x2 grid, as long as all the pieces go together and we can fill that space, it's more engineering, planning, and that's how you get different sizes and shapes onto a ceiling.
Awesome. All right. How do these floating ceiling panels work with sprinkler heads?
Depends on your local code and jurisdiction. In some places, when you're like most of those, when we suspended them, if you could see the suspension elements, we would use like an aviation cable. A lot of times you're going to have to sprinkle above and below or penetrate them just like a standard ceiling. Once again, it's going to be up to the local codes, local jurisdiction. Sometimes you can put them high enough that the sprinkler heads will be below them. And then if you're using metals, those are non-combustible materials. So a lot of times they're not worried about if you don't have a fabric or something that can combust on it, they're less apt to make you go above and below.
All right. Cool. Do you do custom perforated panels?
We do. We have some in-house abilities, and then we work with a perforator outside. But we are expanding those capabilities all the time. I don't know where it went. We used to have one that was a logo. We have just redid some of our headquarter facilities, and we're able to do the ATAS logo and beams in a custom panel. But yes, the answer is yes, we can do it. If we're looking at large format, or we're putting together multiple panels, we work with a perforating partner.
Cool. All right, looks like we've got time for maybe one more. Are you approved with hotel brands such as Marriott, Hilton, etc.?
We have a national accounts person that generally works with those national accounts. I know that we are doing Fairfield Inns. I know that we've done loft hotels. But that would be Jason Richter, our national accounts manager, that would do it. So the answer is yes with some of them. But yeah, so we try to cover the country, basically coast to coast. So no matter where you're coming from, we have a manufacturing facility in Mesa, Arizona. That was the triangle panels. I'm here in the headquarters in Allentown, and we just recently acquired a space to handle kind of the central plains and Midwestern states up in Chicago. So no matter where you are, folks ever want to reach out, come see a plant tour. Once again, my information's up there. Please, by all means, we're always happy to oblige.
Awesome. All right. Well, with that, looks like we are at time. So just want to thank everyone today so much for coming out and participating in today's webinar. And thank you, Kevin, so much for a really great informative event. You know, there may be a handful of questions we didn't get to, so we have a record of them. Don't worry, we'll share them with the folks who need them, and we can follow up about those after today's event.
Shoot them my way and I'll get them answered. Thank you very much.
All right. Thanks, everyone. Hope you have a great rest of your Thursday.
Bye-bye.
Bye.